Today we are going to see how we can set up a GraphQL server and learn a few things about GraphQL. So first I'm going to set up a node server. GTS is a boilerplate for setting up a node server using TypeScript. We are going to install Express server and Apollo server. We are also going to install NodeMon and TS node as dev dependency. First, let us open our GraphQL project with any code editors. Create a chart. Here we are using NodeMon and giving our source file, and we are going to use TS node as the executable. We are importing our Express, import our Apollo server, and then we are going to create our Express app. After that, we are going to create our Apollo server. Then we are going to apply our Apollo server to our Express app. Start our Express app. Now that we have created our Express server with Apollo, we are going to start our server. As you can see, now an error will pop up telling we need type def. So we are going to define our first type definition. Now we need to import GraphQL. We are going to import this type def to our application. Now GraphQL server is started. Now that we have created our Apollo server, we can go and see our server at 5000/GraphQL. Let's go. GraphQL is auto-documented. Here you can see the docs. We are having a query called hello, which returns a string. Let's try that. The GraphQL is auto-completion and we can see hello. Let's select hello. And let's run our query. Here we got hello as null. Now let us see how we can give value to the hello. Let us open VS Code. Define something called resolver. Now we have to define query because we are querying our data. And since we are calling hello inside the query, we need to define that. And we are returning hello world. Let us assign resolvers to our Apollo server. Save the app. And let's reload our GraphQL and execute. Now we got hello world. Now let us see how we can move our type defs to another file. Let's create a schema.graphql file and copy our type definition. Now let us remove GraphQL type definition from here. Now we should first read our schema.graphql file. And now we need to apply GraphQL to this file. And now let us save this. Let us go back to our file. As you can see, our docs still have string and we got hello world. Now we are going to open VS Code and see how we can move our resolvers to another file. For that I'm going to create a folder called resolvers, and then I'm going to create a file called query.ts. Now I'm going to create our first query and I'm going to export this, and I am going to remove this. Then I'm going to import our query. Now let us take our app. We got our hello world. Now you can see there is something called tracing. This is disabled to enable. You will give tracing is equal to true and save this. Now we go back to our application. Tracing is an awesome feature. And let us see what are the different types available. So there are 5 types available. One is int, float, string, boolean, and id. Let us give an example for each. Now we have given types, defining 5 of them with 5 different types, updating our resolvers to this. For value, we have given a number. For weight, I have given a float. For ID, I have given a unique identifier. And for success, we have given a boolean value. Let us save this. And let us go to the application, refresh this, and see our docs. We have 5 types, and if you see, we have ID, we have value, we have success, and we have weight. So we got all our 5 values. And if you want just ID, you can request that. That is the power of our GraphQL. We can require only what we need. We are going to discuss about another GraphQL data type. For example, we are creating a topic and we are allowing this a string. But the problem is we are allowing only specific topics. For this, we are using enum. So now we have created an enum called block topics, and we are giving this to the topic, which is our resolver, and we'll create our topic. Here I have created a topic called hello. We are going to our application. When we execute this, we got an error because this is not an allowed topic. So we look into the topic, we have web. So we are going to give this web. And now if we execute, we got web. Now we are going to see how we can bring all this variable outside the query file. So for that, we are creating our db.ts file. We are going to copy all our query variables to here. We are going to index and we are going to import the db. Now we are going to assign this db to our Apollo server. Now the db is available in the context. So we are going to modify this. So each definition will be having 4 variables. One is parent, second one is arguments, third one is context, there is a fourth one called info. Now our context is having hello, value, weight, and success and topic. Now let us go to our browser and try executing this. Now we are going to build a simple application. So in this application there is user, the user has ID, email and name, and there is a post, there is ID, title, body and type. User create post and there will be an order for every post. So first we are going to create a single user and a single post. This is our schema. So we are having query, user and post. I am going to create our user. User have ID of type ID. The exclamation means it is a required field. Then we are going to create our post. Then we are going to create query. There is one user of type user and a post of type post. And we are going to create our file. So there is a user and a post that will return the user and post from the context. As we go to our DB, and we will define the users and post. And the next skill we got Bob. We can request for post. And we are going to ask for a title. We get the title. But if we try to access or the post, we will get an error. Because although we have given The author is ABC. We have we are giving the user when user is called, and we are giving post when post is called. First, for this we go to our schema. We are defining our post and user, and we are going to create our user.ts file. So here from the user, we are calling a post. So the parent will have an ID, and our post will be having an author. So if we check if the author and ID matches, we are going to return our post. Similarly, we are going to create a post to get the author. So here there is an parent will be having an author, and if we match the user ID with the author, then we can return the user. Now let us import this user and post schema to our index.ts. Now let us execute this. We get title, and if you see the docs, there is user is having post is having user is having post. Now we are going to allow multiple users in the application with multiple posts. So there are user 1, 2, 3, and there are post ID 4, 5, 6. The user 1 has created 2 posts, and user 2 has created 1 post, and no post by user 3. Now we need to update the schema to get the output accordingly. A user can have multiple posts, and we are requesting users and posts. So we need to modify the query with users and posts. Then we need to add our change the data inside the user. We will get an array of posts for a user, and each post will have an author. When we execute this, we get a user Bob, he has 2 posts, a user John, he has 1 post, and Sean, who doesn't have any post. Now we are going to create our second query. Now we have created our second query, we are requesting post and author with its name. We are executing second one, and we got first post with Bob as the author, React.js with Bob as author, Kingsman with the author as John. Next we are going to see how we can pass parameters to the backend. For example, we need to find certain posts. So here I added a search parameter called data, and then we are going to our query. The data sent from the backend is received as argument. It has parameter data. So if there is no data in the argument, we'll be returning our original post. If it is present, then we will be checking. If it exists, we will filter that and return it back. If we execute, we will get 3 posts. And now I am going to send data with parameter awesome. There are 2 awesome, one over here and one over here. Now I am going to send. Now we got 2 of them that matches the search parameters. Now we are going to create a new user. For this we are using mutations. Create a type called mutation. It create user. We are passing that parameters needed, and we'll be getting a user in return. So what can be the data? We can give like this, but there is a more elegant way. So here we have created an input type called create user input. This is the naming convention. And then we'll be giving name and email as input. And then we give data as create user input. After that, we'll be creating a mutation file with create user, with parent arguments and context. First, we'll be checking if the user exists. If the user exists, we will throw an error. If not, we will create a new user with the parameters that is passed along with an ID that we will be creating. After this, we will be adding this user to our users array, and then we will be returning the user. Now we need to pass this mutation to our index. Now if you go to our application and execute with these parameters, mutation, create user, data with email and name. We get a user access error because Bob already exists in our database. Now I change it to Joe, and now we execute. We get a new user. We can go back and see the user, and we can see our Joe White is over here. Now we will see how we can update a user. So for update also we'll be using mutation. So I have given update user. This is the user for whom the parameters will be updated. And for data we are giving the update user input definition. Name and email are optional parameters because we have not used exclamation mark, and we are giving data as update user input type. From here we will go to our mutation. We'll create an update user with parent arguments and context. First we will see if the email they have provided exists. If it exists, we will throw an error. Then we will find the user whom the ID matches, and if no user matches, we will throw an error called invalid user, and if it matches, we will assign the data the corresponding values. Since it is fine, this is mutable due to the reference, and then we will return the user. Here I execute the first one. We got Bob, John, Sean, and here I have given Rob. We get a username with Rob for ID 1, and if you execute over here, Bob is changed into Rob. To reading any data, we will be using query, and for performing any changes, we will be using mutation. It can be to create, update, or delete. We are going to discuss subscription. It is a different way to obtain the data. GraphQL uses WebSockets to get the data. We have to do a little bit of configuration. And if we are importing our PubSub, we are creating an instance of PubSub and we are providing it to the context. We are starting our HTTP and HTTP server, and we are applying this subscription to the HTTP server, and we are listening to our HTTP server. Next we are going to our GraphQL schema, and we are defining our GraphQL schema. Here we are calling user with user ID, and we are returning the user. We are going to go to our subscription. So if you see query, we are calling users as a function. Here in subscription, user is an object with subscribe as a function, and we are giving our user parameter in our subscription. Now we find if a user exists in DB. If user does not exist, we cannot subscribe. If user exists, we are calling an async iterator from PubSub, and we are subscribing to the user ID. Next we are going to our mutation. Here is where the update is happening. Now we are going to publish to user ID the value of the user. Now we have to go to our index and import the subscription. Now we will refresh the app. The app is listening. I'm going to update the user. We got the raw. We try to update again. We get each time the data because update is happening. And you can see the update over here. So this concludes our part 1 of GraphQL with Node.js. Thank you.